Now, let's look at a basic overview of the term structure of the interest rates. Now, this is more to understand how the interest rates, when we talk about the word interest rates, there are different meanings of it. In some cases, we can talk in terms of the spot rates. We'll discuss about each of them. In some cases, we'll talk about the forward rates. Again, within this, we can even talk about the instantaneous rates, instantaneous spot, instantaneous forward rates, or we can talk about the bond prices which are based on the various interest rates. So, whenever we are looking at the interest rates, any of these definitions of the interest rates, how they are changing with time, that kind of concept is associated with the term structure. We are trying to model the interest rates over time. What are the various theories that are behind the modeling of the interest rates over time? That is what is typically being covered as a part of this introductory session. Now, just to get acquainted, here there are quite a few important terminology that would be covered. But yes, before that, let's understand a simple structure. Okay, I'm taking a simple timeline, right? I'm taking a timeline. This is a time period 0 when some investment might have started. This is a time period T, which is today, right? And let's say this is one more time period, capital T, where probably a bond would be matured. Or you take one more time period S, where a loan might get initiated at time period T and would be paid off by time period S. So take the meaning of T in two different cases. In one case, you take this T as the time at which a particular bond that was issued is going to mature. In one case, you take this T as something which a person is thinking today that he wants to take a loan at time period T and want to clear it by the time period S, which means the loan taking period is S minus T. So if I look at these different kinds of time periods and different kinds of amounts, I assume that when the bond is maturing, it is giving me a face value of 1. Here, wide varieties of terminologies are going to come up to understand the term structure. First of all, the bond which is maturing at time period T, if I want to find out the value of it as of today, we represent it as BTT, or basically this is like at time period T, I want to measure the value of the bond which is going to mature at time period T. So this bond, we call it as a zero coupon bond. Intermediately, no cash flows. It's like from T, if I look at, it's not paying anything here, no coupons in the middle. Only the final maturity amount is happening at time period T. Then the present value of it, I am simply writing it as the BT comma T. That is one important notation that we typically use, which is talking about the price of the bond as of the period T, where it is paying a cash flows of some $1 at time period capital T. And in this, we denote another variable r, small r, which is called as the short term interest rate, or typically called as instantaneous risk free rate. And so at time t, whatever, as on today, if I'm assuming t is today, as on today, what is the risk free short term instantaneous interest rate? So that's one more term we need to be comfortable with. Then I'm talking about the forward rate between T and S as of today for a loan which is going to start at time period T and is going to be paid at time period S is typically called as the forward rate. The forward rate at time T for any kind of a delivery between time period T and time period S. That is what we call as the forward rate between that particular point in time. But if I just denote only T without S, then it means it's an instantaneous forward rate. And instead of small r, if I am writing capital R of t comma t, we call that as the spot rate. So these are the various definitions. So spot rate is that particular interest rate which is from t to t, the entire period between t to t. What is the overall annualized interest rate that is going to come? So it is primarily, this is a bond which is maturing at time t. I am trying to find the value of it as of today. Now the same logic, if I look at, if a bond is maturing at time period t and is priced some b of t comma t today, what is the interest rate for this entire period? That is what we are calling as the spot rate for a bond that is going to be matured at time period capital T, for which we are finding the value at the current moment. And there is one more term, probably if I have invested some $1 at the beginning of the period at time 0, if I want to know the future value of it at time period T, we call that as C of T. The cash flows for 1 unit of investment at the risk-free rate of return. So these are some of the very common terms, right? These are very common terms that are very much applicable. But one thing we have to appreciate is these values may not be a constant. They may keep changing based on the T as well as the capital T. So that's the reason the modeling of the interest rate becomes more and more difficult compared to the modeling of the share prices, because the models of the share prices, they are primarily dependent only on the time, whereas the modeling of the interest rates, as we are seeing here, they are dependent on the time as well as the maturity period as well. Because for a shorter term maturity, the interest rate could be different, and for a long term maturity, the interest rates could be different. So that's one major area which makes the modeling of the interest rate slightly more complex compared to the modeling of the stock prices. Now let's see a small thing. How do we find the relationships between the various stuff? Now, the first important thing, computing the spot rates. It is as simple as 1 by t minus t log BTT, because if you see, BTT is the price of the bond which is maturing in time period t as of today. as of the time period small t. So, it's as good as if if something is invested at time period t, it is going to become, what is the value of it at the end of it is going to become 1 at the end of the time period capital T. So during this process, whatever is coming out, that is what is the typical spot rate which we are talking of. So it's as good as, now if something is invested at time period T, it will fetch a continuously compounded interest rate between T to really become, right, a $1 today. If I am investing it for RTT period times the T minus T, RTT times, this is an annual rate of interest, this multiplied by T is going to be, or probably if I am talking about the BTT, investing for this much period is going to become 1, because this is the price of the bond which is going to pay 1 on the maturity. The maturity is T minus T periods away from now. So just writing it the other way, e power RTT times T minus T equal to 1 by B T comma T. Again taking it out, R T comma T times T minus T is equal to log 1 by BTT. Log 1 by x, I can very well write it as minus log BTT. So from here I can very well write RTT is equal to minus 1 by T minus T times log BTT. So this is what is the relationship between the spot rates and the price of the bond. One important relationship which we need to be comfortable with, the spot rate between time T and the time to maturity capital T comes out as minus 1 by T minus T log B of T comma T. In other way, probably as I said, log B T comma T is equal to minus R T comma T times T minus T, or BTT becomes e to the power of minus R T comma T times T minus T. That's one relationship which we need to be comfortable with. Now once I know the spot rate, I want to know the forward rate between the two. I want to know the same logic if I am putting up BT comma S is e power minus RT comma S minus T. This is what is going to happen. Now this is the price of the bond which is maturing in time T. This is the price of the bond which is maturing in time S. Now I need the price between T and S, right? That's the reason, that is what will typically give me the forward between the T and S, which actually works out as 1 by S minus T, the log BT comma T divided by BT comma S. Because if you see, just divide these two things, what is it coming out? E per BT comma T divided by BT comma S is becoming e power minus RT times T minus T divided by e power minus RT S times S minus T. So this is what is the value of the interest rate, between T and S time periods. Right, this is what is becoming the value. So basically if you expand this, it's as good as e power, right, this is directly ft comma t. I'm taking the logarithm between these two. So I take the logarithm between these two. Log a by b becomes log a minus log b, right? So it is becoming log, so when I'm taking log a by b, it is becoming log a minus log b. So in short, it is becoming minus r times t comma t times t minus t minus r times t comma s times s minus t. Now let's expand it. Minus t r t comma t plus t r t comma t. Again, plus s r t t comma s plus t r t comma s. So in short, if I am dividing this by s minus r, so basically I can take out s minus r. Now once I am s minus t. Now once I am taking out s minus t, dividing it by it, I am getting the interest rate purely between time period t and s, discounted to the present value. That's the reason we are calling it as the forward between t comma t. Looking at from a small t's perspective is like nothing but the value of the bond which is maturing at time period t divided by the value of the bond which is maturing at time period s. Take the logarithm of the division and divide the whole by s minus t. And out of this, if I want to know only the instantaneous forward, then simply it's as good as take the limit as s is coming closer and closer to t here. S is coming closer and closer to t, it becomes nothing but the dou by dou t of log b t comma t. So the instantaneous forward rate comes out as the logarithm of the price. Take the logarithm of the price and take the derivative of that. Logarithm of the price and take the derivative of that. So which means I can very well write the f of t comma t is nothing but minus dou by dou t times logarithm of bt comma t. The other way now, bt comma t, if I have to write it the other way, it becomes an integral. E to the power of minus integral between t comma t f of t comma u du. So this is how we can, if at all I have an instantaneous forward rate, I can use that instantaneous forward rate to find out the price of the bond. If I have the price of the bond, I can use it to find out the spot rate. So any of these things can be derived once we know the relationship of the others. And at the same time, if at all I am trying to understand the structure of all these things across the time, we are typically calling it as the typical term structure of the interest rates. Now let's look at one simple example to see how we can convert from one to other. We have one simple numerical which says the instantaneous forward rate is given to us like this: 0.03 times e to the power of minus 0.1 times t minus t plus 0.06 times 1 minus e to the power of minus 0.1 times t minus t. Now with this, I want to find out bt, I want to find out rt. Now we know that bt, to first start off with the bt for time period t, it's as good as e to the power of minus integral between t and t f of t comma u du. Now the same logic I'll apply, e to the power of minus integral between t to t f of t comma u 0.03 times e to the power of minus 0.1 u minus t plus 0.06 minus 0.06 times e to the power of minus 0.1 u minus t dt du. Now just another simplification, e to the power of minus integral between this 0.06. Now these two can be simplified, e to minus 0.03 times e to the power of minus 0.1 times u minus t du. Right, this is what is typically working out to be the value of the price of that particular bond at time period t. Right, this is what is going to work out. So simplifying it now, I'll make it as e to the power of minus this, I'll make it 0.06 u, which would be integrated between t and t, and this becomes minus 0.03 divided by minus 0.1 e to the power of minus 0.1 times u minus t. Even this would be integrated between t and t. Now this is becoming e to the power of minus 0.06 times t minus t plus 0.03 by minus 0.1, which becomes 0.3 times e to the power of minus 0.1 times t minus t minus of the remaining stuff. So this is becoming minus t and again plus 0.3 times e to the power of 0, which is becoming 1. So this is what is typically working out as the price of the bond. Minus 0.06 times t minus t plus 0.3 times, right, e to the power of minus 0.06 t minus t plus 0.3 e to the power of minus 0.1 times t minus t plus 0.3. This is becoming the price of the bond. Now we know the spot rate RT comma T is nothing but log. So I have to take the log of this. So log of BT comma T will become minus 0.06 T minus T plus 0.3 e to the power of minus 0.1 T minus T plus 0.3. So this is log and minus 1 by T times that. So I'll minus 1 by t minus t times this entire value. You can very well simplify it and say this could be the spot rate associated with this particular instantaneous forward rate. So that's how we can find out the relationship between the various price, spot rate, instantaneous spot rate, instantaneous forward rate of the securities. Try modeling the interest rates over a period of time. So this is the basic introductory element as a part of the term structure of the interest rates.